In our PEPR 21 talk, No Threat, No Sweat, we will bring privacy threat modeling theory into practice. I'm Kim Waerts, an academic researcher at IMEC Distrinet, which is a research group at KU Leuven. And I'm very happy to join forces in today's talk with Isabel Barbera, a privacy engineer at Businesswise. I will first introduce threat modeling in general and present our LINDDUN privacy threat modeling framework. Next, Isabel will explain how she adapted LINDDUN Go to fully align it to the machine learning use case she's working on. I think all of us here agree privacy is important and it should be applied early on by design. But that's easier said than done. How do you actually apply privacy by design? Let's look at some of the characteristics of the privacy by design paradigm. Privacy should be tackled proactively in a systematic way. So that means it should be integrated in the development lifecycle early, so it can have an impact on design decisions later on. In addition, privacy, data protection, they require a risk-based approach, as for instance stated by GDPR. Now, all these properties actually describe a technique that is already quite known in the security community, and that's threat modeling. Now, the Threat Modeling Manifesto describes the foundational values and principles of threat modeling, so you will see me referring to it on several occasions throughout this talk. This definition of the manifesto describes threat modeling as analyzing a system representation, a system model, to highlight security and privacy issues. In other words, threat modeling is basically thinking about what can go wrong so you can fix it early on before the issue actually occurs. Now, before you can think about issues, you need to know what you're working on. You need to have a good understanding of the system you're analyzing. You need a system model. Then you can systematically go over all of the system components and think about what can go wrong. Once identified, you will want to tackle these issues. And finally, you will want to reflect on the analysis you have done. Now, these 4 questions were coined by Adam Shostak, and they actually describe the threat modeling process. How does this look like for privacy? Well, we created LINDDUN, a privacy threat modeling framework 10 years ago now, and we were inspired by Microsoft's Stride. So those familiar with Stride will see quite some similarities. The process aligns with the 4 steps I mentioned before. First, you create a system model. In threat modeling, that's often a data flow diagram or DFD, but also different representations are possible. Then you elicit threats. Of course, you need to know how to systematically do that, but you also need to know what privacy issues you're actually considering. So, in addition to the process support, LINDDUN provides knowledge support structured according to the 7 threat categories captured in the LINDDUN acronym. What it does is, for the elicitation step, provide an overview of potential privacy threats for each of those categories. And also in the mitigation step, LINDDUN provides knowledge support to help identify suitable privacy strategies and solutions. If you like more information about this, you can find everything on the LINDDUN website. In the past years, we have seen that LINDDUN has been gaining some traction both in academia and industry. For instance, it had been included in the ISO on privacy engineering. It has been mentioned by ENISA and EDPS in their documents on privacy by design. So we're really excited to see that. Now, in the remainder of this talk, we will primarily focus on the threat elicitation step. How do you determine what privacy threats apply to your system under analysis? And to help with this challenging exercise, we actually extended our LINDDUN portfolio last year with LINDDUN Go. LINDDUN Go aims to provide a lean and collaborative approach for privacy threat elicitation. It's essentially a deck of privacy threat cards that will guide and inspire a joint privacy threat modeling exercise. So, what do you need to get started with LINDDUN GO? Well, I mentioned it before. First, you need a system model, a system description. And as described by the manifesto, there basically is no single best representation for threat modeling. You use whatever works best for you. And for LINDDUN GO, that can even be just a basic whiteboard sketch. Next, you need a deck of LINDDUN GO cards. I want to note that this should not be considered a checklist, but it's a tool to inspire, to drive your creativity. And finally, you also need a group of subject matter experts. Now, what does a LINDDUN GO card look like? Well, it's basically loaded with a lot of privacy threat information. You have basic summary title, but it also provides examples, information on consequences, on impact. And what I think is even more interesting and more useful is the questions to help you determine the applicability of the threat card for your system. And also, there are hotspots that describe the places in the system that are most susceptible to the described threat. So that also allows you to quickly scope the analysis for each card. Okay, we have the cards. Now, how does it work? Well, it's very easy to process. Each participant takes turns, picks a card, discusses it, and then there's a group discussion to see whether there are any gaps. By doing this systematically in a structured way, you achieve thoroughness, you achieve reproducibility. And then, of course, each identified threat should also be documented because these threats can and should have an impact on further design decisions. Okay, so this was the privacy threat modeling theory. Putting this into practice is basically a matter of refining it to local needs and preferences. And Isabel will illustrate how she adapted LINDDUN GO and successfully applied it in a machine learning use case.
Thanks, Kim, for your great introduction. I am Isabel Barbera, and it's my pleasure to take you through this second part of the presentation. I've used LINDDUN before in previous projects, and I was very enthusiastic. And about a year ago, I started a new machine learning project, and I thought it could be really beneficial to implement LINDDUN there. But I also saw immediately some shortcomings in relation to machine learning. It was clear to me that I needed to adapt it to make it work. And this is the story that I want to share with you today. But let's start with a quick background overview of the use case. So we have an organization with their own data analytics department. One of their activities is fraud detection and, of course, predictions. And they find behavioral analysis quite interesting. And then they're working on what we could call a soft agile environment. And it's important to mention that as with any introduction of something new, you need to motivate your stakeholders. You need to find sponsors. In my project, there was no clue what threat modeling was, let alone privacy threat modeling. So as you can imagine, I had some resistance. But what helped me to sell it, in my case, was when I told them that it could generate good input for privacy impact assessments. So try to find your selling points, I would say. And let's look at how I adapted LINDDUN. I realized some months ago that I could not use most of the threats proposed in LINDDUN. And I was missing threats more specific to machine learning, like for instance, threats related to data quality or bias. So I decided to create a library with new threats and categories. And this is the result of months of research work, analyzing different sources of information, like white papers, guidelines, best practices, articles, and blogs, and even the new EU proposal for an AI regulation. Like you can see here, the categories technique, ethics, accessibility, and security are new. And also some new threats have been added to the current LINDDUN categories. Especially the non-compliance category has been the one more expanded. I imagine you are wondering what the library looks like. And I won't show it today to you, but I will tell you that it's almost ready to be published. And I'm planning to make it available in a few weeks. So please just bear with me. In the cards of LINDDUN GO, we see per thread scenarios and elicitation questions. In my experience, I've seen better results with the use of questions. Maybe because some people find it more difficult to visualize certain scenarios. So I decided to take the question approach in my use case, because questions help to bring focus and facilitate engagement. And this can be a beneficial approach, especially in the design phase where there's a lot to decide and to discuss. But the use of scenarios is, of course, also a valid approach. Just choose what suits you better. So just to summarize, the result after the adaptation of LINDDUN is a library containing new threads and categories specific for machine learning. And every thread containing scenarios, elicitation questions, and proposed mitigation measures, like what we see in the LINDDUN GO cards. In privacy, it's essential to look at the data lifecycle. And that's why you usually look, for instance, at input, output, storage. Machine learning is an iterative process where data plays an important role in all the different phases. I realized that it was important to look at the development methodology that we were using when creating our models. What we were using was a combination of CRISP and the SAS analytics lifecycle. In comparing different methodologies, we can see that most of them consider similar phases that involve the whole data lifecycle. That is why it's important to consider them if you want to capture all the possible threats. So based on that, I decided to create a set of simple phases to make it more accessible for non-technical stakeholders. And as you can see in the table, our building blocks are much more simple than the ones used in other methodologies. Design, input, modeling, output, and they can be easily aligned. For instance, the input phase will contain the data understanding and data preparation. And maybe nice to mention that in the new library will be specified to which different phases and methodologies each thread can be applied, just as a suggestion. And as we just saw in our use case, we kept the data flow diagram simple, but this can be eventually adapted to more complex environments, like when you are collecting data from other systems or storing your models in the cloud, sharing the data with third parties. For LINDDUN GO, we use a set of cards, but here we didn't have cards for the new threads, and a lot of people is working nowadays remote. So what we used was simply a PowerPoint with questions, a video conferencing tool, and someone taking notes. And it doesn't sound ideal, but it worked. And this is an example of a slide that we used during one of our sessions. It addresses the output phase. And as you can see, there are 4 questions related to the categories technique, ethics, and linkability, every one with different colors. During the session, we discussed per question if they are a possible threat. And if they are, then we classify them. We decided to keep it simple, just using low, medium, high risk. And we document the actions, and the threats are added to our project backlog. And the approach is to work on easy fixes first and follow up on the rest. At this moment, we are holding a privacy threat modeling session per sprint as an extra refinement. And we have a group of data scientists, project managers, and architects that are being trained in privacy as privacy champions. They are also being trained in privacy threat modeling to learn to facilitate the sessions and to prepare them, selecting the right questions. During the first test session, we experienced the direct benefits of threat modeling. We identified important threats like these 2 examples I will show you now. When asking if the model had to be explainable, we saw that this could be a possible threat because until that moment, based on the requirements collected, the data scientists were considering an approach that could have a negative impact for explainability. So this triggered a change of course to look into other possible models and ways to mitigate this threat. Another example is about the threat related to the output of the model. So when asking if the output will be used as input to feed the model, The team realized that to fit a model preventing bias, they had to probably move away from their original plans. This was a really interesting case. And we have held already a few privacy threat modeling sessions, so I would like to share with you some of the feedback that we have received so far from the participants. So as you can see here, it's a journey that helps us to be better. The whole organization benefits from it. In the meantime, risks are being documented. We have seen things we had not seen otherwise. I find a really nice comment. And yes, with such a positive feedback, we are of course really happy. And looking forward, what are our next steps? We have some process-related questions like, should we add impact and likelihood? How to prioritize risks? And should we establish some privacy acceptance criteria? And this could also help us eventually to better define when a threat has been solved. But we also want to create a register for threats. This could be so simple as labeling issues in JIRA, if that's the tool you use, for instance. And we have a couple of open questions. Can we use threat modeling for feature selection? Currently, we do a manually privacy review of the proposed features, but this takes quite some time and we might benefit from the threat modeling approach. This is something we have not tried yet, but we are considering it. And another question is if a privacy officer is needed. And we see that the role of a facilitator is very important, but that it is challenging if the privacy officer as facilitator doesn't have understanding of machine learning. So training data scientists as privacy champions and have them facilitate the sessions can also be an alternative like we have done. In any case, the privacy officer will always be beneficial as participant. What are the lessons that we learned? We saw that after the design phase, once the requirements are clear, questions that are already being asked in other processes, such as quality assurance and control, should be avoided. This feels otherwise like a duplication of work and creates a lot of frustrations. So selecting the right questions when preparing for the session is very important. Another lesson learned is that a facilitator is needed to guide the discussions. That online is more difficult to give voice to all participants, and that we should not exceed the max of 2 hours per session. And what about the benefits? There were the obvious benefits for the organization, like the improvement of processes. This is because some threats play a more global role. That is why it's so interesting to register the threats and have an overview of what has been registered, what is going on, what has been already mitigated. But we also saw other benefits, like reduction of rework, simply because the purpose is more clear and expectations regarding issues like bias, discrimination, or explainability can be better managed. It also brings all stakeholders on the same page, reducing time spent in endless discussions. And of course, the selling point, the output can be used to document the privacy impact assessments. So everybody's happy. To conclude, maybe in a poetic way, I would like to say that by applying privacy threat modeling to machine learning, we have learned to humanize the machine. The combination of human and machine learning is clearly beneficial for the creation of safe, respectful, and privacy-friendly products. Thanks for your attention. Also on behalf of Kin, of course, happy to keep in touch. Thank you.